the Andover Historical Society to give a presentation on the rocks of Andover. Now when you start talking about just the rocks of Andover, you could have a very short conversation about that, or you could drag it on for an hour. Okay, well, I'm going to say embellish the time, because when you ask a geologist just about a rock and he throws a name out to you, it may not mean much to you, but a geologist could go on for easily an hour talking about what's related to it. So that's one of the reasons, let's say, Junie had mentioned, oh, let's have a title of Andover Rocks. But I said, well, there's more to it. So, you know, make it a little bit lively. Rockin' and rollin' in Andover. What are you laughing about? You're thinking of something else. When you start talking about the geology, you'll find out over the last 500 million years, there was a lot of rocking and rolling going on, and as I said, through the ages. In the background is one of your typical outcrops here in Andover. Sometimes you can't even see it because there's so many vines and poison ivy over everything. But we will get into that as we go through. Some other things we have is just the bedrock, they call it bedrock geologic map of Connecticut, meaning that once you have the bedrock, you've gone through all the soils, and the next place you're going to wind up, if you drill through this, is sort of that hot upper part of the mantle. You don't want to go there. Plus, they have never been able to anyway. So all the different colors represent different rock types through here. So even though, like I teach science, the kids enjoy the colors, they're not really interested in the meaning of anything. I hope you're interested in the meaning. Okay, notice I have a couple of things outlined. Here's Andover, relatively small town for the whole state of Connecticut. The other one I have outlined is for Simsbury, where I live and teach. So we can sort of compare things as we're going along. Okay, could you put the lights out now? No, I was just giving an overview. You're certainly welcome at the end to come up, and at times I'll just reference different things. But in your handout, so you have two handouts here. One is a very basic outline, bedrock geologic map of the state. And you see all these various colors, and we even have a legend in the lower right-hand portion of that. And note already you can break up the state into about maybe 3 or 4 segments. And we'll get into this, because if I just tell you the rocks out here are primarily nice, and that's not being complimentary either, because it's a German word, G-N-E-I-S-S, referring to the type of rock. There's a lot more to that when you say that it's a gneissic type rock. So that's the first page. And the second page is an abbreviated geologic history. And we're dealing with sort of the first 500 to 600 million years. All right, that's all I can cover in an hour. I can't do another 4.5 billion or 4 billion years in any other time frame. So I'll be talking really fast through this whole thing. Okay, just to get you through. So this is sort of a reference, because as we're going through, going backwards, we'll be talking about that. Some other things. Okay, we have rocks up here, of course. This is a geology discussion, so we should have rocks. Now, the rocks are laid out just like the state. So you're going to find out you're living in the Eastern Highlands. So I'll have to move over here. Eastern Highlands. So your prominent rock type is displayed right on the top here. We have another piece of the rock here, actually split by Junie in her spare time. Okay. Hello.
Wrong entrance, sorry.
That's all right. And then we have the center part of the state, the valley, and we have some typical rocks from around there. And then we have, of course, the Western Highlands. Maybe you notice I put the block up there to indicate we're up high again. And then we get over to like Danbury and such, and we have this marble. You know why marble is sitting in the state? Well, we'll tell you why. Then we have a few others. We have your basic rock types, or let's say, I say mineral types, meaning all rocks are usually made up of this guy here, which is quartz. It's not a fossilized egg. Okay. Feldspar, another one of the big 3. So you have quartz, feldspar, and of course, anybody know the third one? Yes, Roxana.
I'm not saying a word.
Oh, okay. And mica. Oh, sorry, I didn't see your hand. Most of the time, I'm usually looking down there. Most of the time I'm looking at the kids in the back row who are fooling around. You two are already starting. We're going to be separating them. And then we have hornblende too and garnet. Okay, so this is more massive hornblende and garnet, and certainly the mica, to give you examples of what every rock, meaning like your Andover gneiss, is composed of here. Okay, so where are we going to start here? Rocking and rolling through the ages in Andover. Okay, get into our first one. Oh, okay. As the survey says, why are you here? Are you a friend or related to Dorothy Yeomans? Raise your hand, please. That's what I expected, and thank God she has a lot of friends. 2, how many, you love to spend Sunday afternoon listening to geology talks? All right, I got a few. 1 I honestly know about. It's like, yeah, thank you, Roxanne, for showing up. Okay, so we know why you're here. Okay, we'll try to get you out by the half of the Patriot game. Oh, you can't leave yet. You're the one who wanted this. Okay, as I said, in a rock's name, there's a lot to a geologist when you say something. There is a story, and usually some mystery behind it, a puzzle, because we don't know anything, a forensic tale, because you got to go searching, and many times it winds up bloody, because you ever have one of these rocks fall on your hand? Yeah. The name begins the story, and that's what we're doing now. You must understand the life of a rock to really appreciate it, what it's been through. It's had a difficult life. Around 100 million years. It goes through some good times, bad times. And rocks are your friends, because at first you're swearing at these rocks. My God, I'm digging. There's another rock in the way. But then later on, you look back in the fall, you see all these beautiful rock walls. And they advertise in the Connecticut thing, come to Connecticut, all the beautiful rock walls. So that's right, rocks are your friends. Okay? Everybody loves rock and roll, right? Okay, we go through. Oh, yes. Another thing. Food and drink. Everybody loves food and drink. Can explain many of these geologic processes that wind up with the certain type of rock we have here or there. Okay, so this is boiling pasta up here. I have the pasta. Just as a visual reminder. That, by the way, there's not much left. We really need to get some more here. Okay. We also have an egg. Actually, we have 2 types of egg here. One, obviously, is a what?
Boiled, hard-boiled.
Hard-boiled egg, and the other is raw. I brought the raw one. Okay? And understanding these things, you'll have a better appreciation of how everything evolved. Okay. Then you have the last one, scotch and soda. I did bring it, but we stopped at Junie's and ate, and it's like, how can I just... I mean, she was offering ginger ale. It's like, I'll have the scotch and water on the rocks. But this you'll find out. I'm not pulling your leg. This explains a lot of things. And yes?
A lot of different minerals can also be used for in your everyday lives, like glass.
Yeah. Salt.
Yeah.
Yeah.
And other things like that.
Yeah. That's right. He's talking about all the other minerals in the fine ores, gold and silver, aluminum, iron. Yes. Milk?
Talc.
Talc, yes. They just said milk. It's like, they haven't found a good use for, anyway. Let's go on. Okay. Where'd I leave the thing? Here it is, behind the rock. Okay, so we're unraveling the mystery. So welcome to a Rockin' and Rollin'. We're going to go from top to bottom, look at Andover over almost 500 million years. What picture do I have there? Anybody recognize what it looks like?
Stairs.
Yeah, spiral staircase. So starting from the top, meaning the present, and going down. Some people say going downhill. So this is just one way they picture the geologic time scale in this spiral fashion with the present, and then going down and down in time. We're going to make it a little bit simpler, because as you see, you have a column there. Now, so if we start from the top to the bottom, or top or the present, where are we? We are in the Cenozoic era, which is on that sheet. Okay, we're in the Quaternary period in the Holocene epoch right now, because it says from 10,000 years ago to the present. You'll find out why they decided on 10,000 years. And then, of course, you don't have this, but the Pleistocene, which is part of the Quaternary, is also noted as the Ice Age. Then from there on, we get older. And this is the one you have here. So the Quaternary is up here in the Cenozoic. And then we'll be bouncing down. Mesozoic is known as the era of the dinosaurs in general type thing. We get down to Paleozoic. This is where most of your rocks were formed. Very interesting. Really, life is taking off in this period. We have a lot of rocking and rolling, a lot of smashing together and splitting. And the Precambrian we're going to hold off on. But we will take a look into the future of Andover and the rocks. Anybody want to stop me now for a question? Okay, we'll keep going. You don't hesitate. So this is sort of a geomorphological picture of your state. So you have the Western Highlands, as we said, and you can sort of look at the rocks over there. You have the Eastern Highlands, which certainly covers Andover. And you have the Central Valley. And then you have some of the main roads going across here, just showing you. Here's the Marble Valley. Has anybody been to the Marble Valley? Okay, so you know that well. Okay. Go on to our next one. And we get into a little bit more geologic. So now they're being broken up into some former landforms. Proto-North America means the original North America craton, which is about like 1 billion years old. The Iapetos, on the left and the right, refer to an ancient ocean before the Atlantic existed. Now it's here. You're living on sort of ocean front, you could say. You'll find out that. And then the Newark Basin, which is actually some area that was torn apart and then filled in with sediment from these massive mountains from the west and the east, and then Avalonia, like sort of Japan, an island arc system that was smashed into the rest of us. And here's the sketch map that you have. What do you think Andover is? Anybody want to point out? Yes? You want to point it out?
I think we'd probably be around over here.
Excellent, yeah, perfect. Yeah, we're just about east or west of this lobe here. Just right in that area. And then you can correlate it with your other maps on there also. So this gives you a good overview. Now, if you want to find out more about all this stuff, that's coming from a lot of stuff, the Facebook of Connecticut, great. And it's online. So you can get the whole thing online and copy images off. And you just put in the face of Connecticut and the site will come up. And then the other major site, if you go to DEEP, formerly known as DEP, now it's DEEP, and you look under Natural Resources Geology, they'll have a whole printout on the geologic history. Any questions yet?
Yeah, Joe.
Oh.
That pink spot in the middle of the green.
Oh, sorry, we passed that already. Well, if you would refer to your map here, it gets quite complex. That's all we're going to say at this point. So I didn't include that. So anyway, okay, now we're back at the top. Welcome to the Holocene epoch of the Quaternary period of the Cenozoic era. All right. So the Holocene includes the present to 10,000 years ago and represents the time since the last major glaciation ended. Okay? We are in an interglacial time of continuing climate warming. And warning too, I guess. I learned this before Al Gore even appeared on the scene. So from the time I was in college in whatever, late 60s, they've been telling us about this and showing us this. So Al Gore is just Johnny come lately. What do you got coming up now? Okay. Well, it's been warming most of the time since 10,000 years ago, except for this little ice age here, 1350 to 1850. In Scott's book, he says, the settlement of Andover, the Andover area, began shortly after the building of the Hartford-Norwich Road, much of old Route 6 and Route 87 in 1700. So this picture of Andover with the yeomans headed home with all the snow there, that's because their snowmobile wasn't working that week. Okay, it's just indicative of this little ice age, because we're trying to tell you that what we've seen in the past before Al Gore showed up is there's been a lot of variation. Okay, medieval warm period now, meaning warmer than what was expected after the glacier melted away, 950 to 1250. While it's unlikely that there were any permanent Native American settlements here, it's certain that they used the area for hunting and fishing because of many arrowheads and spear points that have been recovered over the years. So things have been going on. It was a warmer area. Of course, right after the glaciation, your early Andovians were out. It was warming actually post-glacial times. We're talking about maybe circa 5,000 years before the present. And the deer weren't here, but there were a little bit larger things, mastodons and that hanging around probably, or something similar. No people, the earliest Andovians at that time were really high-tusked mastodons, which they found remains over in New York State and around. I don't think, where they found something here. Does anybody know of anything they found here? They've been finding too much. So this is like 9,000 years BP, meaning they figured everything was melted away around 10,000 years ago. All right, so we have this little chart. Average global temperature over the past 18,000 years. The past 10,000 were in the Holocene. You show right now the temperatures are rising over there, but you see the point of the little ice age, 1350, 1850, and then we had this warming, medieval warming, 950 to 1250. There's no name for here, here, or here. Why don't you think so?
So where do people around to name them?
Yeah, they weren't keeping records and all that. They were just trying to survive 4,000 to 6,000 years ago and such. And then, of course, now you're into your last glacial period, all through this area. So look at just the variation. And then in this so-called warming interglacial time. But yes, what about the rocks? That's what we're here for. Okay, so we begin at the top, as I said. All the rocks and sandy soil are the products really of your glaciers. You know, if you walked right out now and looked at the soil, the top part is 100% organic. Okay? Then you start getting in the topsoil, maybe 50% organic, and then you start getting in your subsoil, and then you start finding all your rocks. Yes, I know some people will say, well, the rocks are also sticking out at the top, too. What's that all about? Well, you know, it depends on where you are in Andover. And then certainly the bedrock is breaking apart due just the frost heaving and just chemical reaction through time. So that's where we're starting with your quaternary or last. Yes? What happened? Oh, sorry. Thank you.
Isn't there 3 kinds of rocks? Sedimentary, metamorphic, and igneous?
Why am I up here talking if you're going to give the presentation? I was just trying to hold the exciting things a little bit later. Yes, and we'll be getting into that as we start talking about the rocks. But right now we're talking about the sediment before it becomes lithified into a rock. Okay, so just be patient. Exciting things are coming. Okay, so yeah, there was over a mile thick glacier right above you here. And tremendous amount of weight. It's even pushing down some of the earth here. It's grinding up everything, breaking up everything, making very fine glacial sands, such as, I have an example here. If you go out and you start digging down, you find nice beach sand, that's going to be glacial sand. If you wonder why I get all this clean, nice white sand around here. Okay? And it's likely you probably could sell it, unless the builder's discovered it and is taking it from you. Because immensely fine and ground down fine, coarse, oh, like beach sand. You think, oh, where's the beach? I have the sand, now I just need the water. Okay, so mile thick ice weathered and eroded significant quantities and really began to form your valleys, enhanced any streams, which continue today. Oh yes, till we meet again and again. Familiar with this? Rocks and more rocks, geologically defined as till. The only alternative is to build a rock wall, a common sight in Andover, right? So they move the rocks. So this is a good example of just till, and you can have all different forms as you're well acquainted with. This is the itinerary map the state has produced for the whole state, and this is a section for Andover. And they give you different color coding for different types of glacial deposits they have spotted. So you have like the swamp glacial deposits. A lot of the light green are just massive till deposits. So just to orient you, this is Route 6 coming down. This is the Hop River. Bunker Hill Road is like coming over here. So this is just a segment of it. So if you wanted to find out what's on your property or whatever, you could just go to that deep site under natural resources and find out. Obviously, these probably, the greenish ones are good for sand deposits and such. And then the other dashed lines, outlines, where they believe there was an end or terminus of a glacial margin, where that glacier melted away and left some sort of remnants of what's called a moraine. And they got other interesting characteristics around there. So glacial deposits from the most recent glaciation. Okay, now we're finally getting there. We're getting to the Pleistocene. So the Pleistocene, as you know, was the Ice Age, 10,000 to 1.8 million years ago. This is what the world looked like at what's called the last glacial maximum. So the maximum point of ice and down south, Antarctica was much larger than it is now. The snows dipped. You didn't have any Great Lakes. A lot of the North Atlantic was frozen, and so on and so forth through Europe, and certainly any high mountain areas. Here's a nice picture of North America. As you can see, the Great Lakes are covered. You go over to here and you see sort of the ending part you can see is like Long Island and Cape Cod. Now I grew up on Long Island, and Long Island's a dumping ground for more than just glacial sand too, unfortunately. And every place you dug there was just sand. You know, I didn't know what a rock was. I thought the world was just made of beach sand until we started going upstate. Okay, so that's where the glacier couldn't go no further. Why don't you think it could move down any further? Yeah, it's too warm, so it was melting at that point. And as this glacier was bringing down tons of material, large rocks called glacial erratics, all the sand material, as it melted away, it just dropped it right there. And we wound up with Long Island. And also Cape Cod, some good things. As you can see, and as I said, Andover was covered by a glacier. Here's a picture of it. Went back to Google Map Archives, August 15th, 20,000 years before the present, and that's the picture. Okay, so that proves. That part of the glaciation, what they call the Wisconsin. All right, interesting picture here. What does it tell you? As I tell the kids, you always want to look at what's on the x-axis, and that's the years from the present going all the way back 800,000 years. And on the y-axis, you have the amount of CO2. You know, carbon dioxide, they're all concerned about rising. They cause another warm period. But if you look at this, okay, we can start from where we are now. Okay, this is warm the past 10,000 years. Then you had the Wisconsin glacial phase, that's cold. So you have warm, cold, warm, cold, warm, cold, warm, cold, warm, cold, warm, cold. So this is warm now. You don't have to be a politician to be as bright as them. What do you think is next? It's like, do you notice a trend? Thank God it's warming, because the alternative is worse. Okay. Here we go. What mystery has been solved by eating and drinking? Does anybody figure out which one's been resolved by now? Anybody thinking which one? Okay, we had Scotch on the rocks. That's why the Scotch on the rocks didn't even make it here. Okay, thinking about the ice on it. The ice is doing a lot of damage to your rocks in that. It's carrying it down. Ice too, as it melts, okay, it always stays up on the top. It's always rising up. And that's what happens with mountains. If I tell you these mountains were as high as the Himalayas, 29,000 plus feet, they were at one time. As they erode and take that mass away, the earth reacts and pushes up the rock from below, always keeping it to a certain height. Isostasy, equal sort of weighting of these things. So that's what Scotch on the rocks is showing. Okay? After you've had a few, you can see a lot of other things too. Yeah, we'll come back to the mysteries. Now we move down to the Mesozoic. Okay, now we start seeing some of the rock here in Andover. So Mesozoic, okay, era of the dinosaurs. We have this big split that's occurring too. Think about it. Maybe you've heard about it. Andover is part of Europe. Okay. And the Mesozoic's made up of the Triassic, Jurassic, and Cretaceous. Triassic is when you started getting the small dinosaurs. Jurassic, as you know from Jurassic Park, you had the nice big ones. And the Cretaceous, they're dying out, and they finally died out with what is believed to be a meteorite impacting around the Yucatan Peninsula. And due to real climatic change, wiped out them and a lot of other species. Okay, here again, what's happening? Well, Andover, in this time, 65 to 250 million years ago, you were on the equator. There was no winter. Get rid of the winter clothes. You don't have to worry. The big split, the Atlantic Ocean was actually beginning to form in Connecticut. And we have plenty of evidence of that. Monsoon-like climate, because now you're on the equator. Times it was hot and dry, other times it was warm and wet. And this evidence is preserved in the rocks. Mild earthquakes and volcanism. That was meaning you're having mountain building occurring here, and there's your mountains. And weather and erosion of the mountainous terrain, which is really a big factor for almost basically 200 years around here. Weathering and erosion. And, so the dinosaur bones were eroded away. That's right. So you had the dinosaurs around Andover, but nothing remained. They were all washed away. Here's a good example of weathering. Weathering defined. Okay? The weather look is meaning really the breaking down of rock, or take it personally, yes, we've all seen that. So it's really the breaking down, the sun, the heat and the cold over in just a 24-hour process. Water in the rocks. Water expands how much when frozen? What's that? 8%, that's right. Good, thank you, sir. Okay, what about erosion? Okay, is your beachfront home with the beach out in front. Okay, and also the drainage pipes leading down to the beach. Okay, so erosion is a carrying away of all the broken down material. And just to emphasize again, you're missing a lot of things here in Andover and certainly all over the eastern Connecticut because it's all been eroded away. Carried down Long Island Sound, the Atlantic Ocean. Okay, early Jurassic now. Early Jurassic. How many people have heard of the supercontinent Pangaea? Raise your hand if you've heard of Pangaea. Okay, good. Almost 100%. So we had this supercontinent. All the continents were connected. And then, in early Jurassic, 200 million years ago, they begin to split. And this is significant for Connecticut, because you see that star sort of right on the water there. and it says location of Connecticut. So it says, what do you note? I already told you, so we can go on. All right, this is a cross-section now through Connecticut and some other areas. Early on, 225 to 145 million years ago, so that's why the Atlantic looks kind of skinny there. But if you look over here in the Hartford Basin, you see, like, if you can see it close enough, like some volcanoes in that. So, and this is black spots supposed to represent magma moving up. You guys are around here, Andover, Amund Simsbury, like over here, 225 million years ago. And we've got these different things called Proto-North America, this arc, volcanic arc, another volcanic arc, and so on. And again, Africa was very close. It was so close, it used to be touching us. Ooh, here's our Central Valley, good old Central Valley. Of course, you people, Andover's up in the eastern uplands, western part of the state's there. I'm here. This Metacomet Ridge. Then you get into Hartford, Hartford here. Really, it's probably West Hartford or something. Anyway, notice it's all dipping down. It was originally laid as a horizontal deposits of sand coming down from these big mountains in the east and big mountains to the west. But then because it was rifting apart, it started to move down on one side. Also, you have all these trap rock lava flows, which is igneous rock. It's known as basalt. And we have a piece here. And what's very characteristic about this, it's only found on the ocean floor. So the next thing you must ask is, so what's it doing there? Well, the original ocean, Atlantic Ocean, the split was here in Connecticut. And so this basalt began to flow out, then cool down and harden. But what happened is, it had a change of heart. So here's a cross-section of the Earth here, and they show the inner core, outer core. Inner core is solid, outer core is liquid. This mantle is sort of a plastic, very thick, but it's still not a solid. And we're talking about thousands of degrees in temperature in here. It could melt anything you had here, of course, even the rock here. And then we have this thin, rigid lithosphere. And does anybody know what these circles, these red circles might indicate?
Magma flow.
A magma flow, but something in general. You're an engineer, tell us. We see them in air, we see them in water. Currents, that's the second word. What's the first word? Convection currents, thank you. Been married to me for 37 years, it finally gets in, finally sinks in. So these are convection currents. Yeah, so there are convection currents within the Earth, and just like one of, let's see if the next one's my food again. Yes, the boiling pasta. So every time you're boiling pasta, you can see what's going on within and on top of the Earth. So the water is supposed to resemble the magma, anything that's in the asthenosphere, that upper part of the mantle, those convection currents. And all the pasta represents is the lithosphere. So you're seeing the noodles moving from the center and spreading out. And that's what was happening in Connecticut. So underneath Connecticut, the magma was rising, okay, and splitting that crust, which is extremely thin, and spreading it apart. Okay, oh, what does that have to do with the whole process here? Geologic process, interesting. I see hands up. Scott has his hand up in the back. No, he doesn't. Like, he's just folded. He's just standing up. Oh, okay, I have an egg here, hard-boiled egg. What may that resemble? You go back to that first.
Earth.
See ya.
Heat.
No.
Earth.
Let's go back. Oh, go back one more. Oh, get a clue? Anybody go? Anybody go?
Cross-section of the Earth.
Oh, cross-section of the Earth, thank you. Who said that? Who said that? Thank you. Okay, because we usually tell the kids, hey, a great model for the Earth. You have a hard shell just like the lithosphere, and it's very thin. You do have a solid core, and you think about the yellow. Yes, the white is not sort of liquidy, but it's still malleable in that. So it still flows. So that's a good example. We'll get back to the last egg in a minute. So we've had three things. So do you understand geology better now that you've... Yes. So you go home and cook tonight, or you think about that egg, think geology. Okay. Okay. Here's a picture from over here on the geologic map of the Earth. The first rock that appears, really the bedrock, is the Andover buttress dolerite. Okay, it's an igneous rock. It's these red streaks going through here that occurred during the Mesozoic, when we had all this tensional tearing from these convection currents coming up, and of course the magma is moving up because there's such great pressure within the Earth that wants to get out. It's like a wound. Like if you cut yourself, what comes out? Magma is right, yeah. It's red too. Blood and magma is coming out. So the same thing happens with the Earth. It's more pressure within it. So we have this, and it's certainly, what's about 5%? It's an igneous intrusion, if you ever find it. Some of it resembles the basalt I brought from the Hartford Basin right here. So if it's kind of really uninteresting, okay, it's going to be the dolerite. So we don't have to spend long on that. It's that uninteresting. Okay, but here's a picture of what would it look like. Sort of has some column jointing to it. You see the basalts around Hartford, that like Devil's Hop Yard. Who's been to Devil's Hop Yard? Okay, you can really see some nice sort of a hexagonal, pentagonal shape of this as it cools down. It almost takes on a sculptured look to it. So, you find the dolerite, find something that's truly black, gray, dark gray, and weathers to brown, probably because it has so much iron in it. Texture, medium to fine grain, sort of a crystalline appearance, but very fine grain. It's mainly feldspar. Feldspar. Here's our feldspar. Good example. Massive feldspar. And the appearance, as I said, a columnar jointing throughout. Aha. Then we have the world. Just to show you again, this is the current situation. Europe is thousands of miles from us. But if you multiply that, we move on average about maybe 2 centimeters per year, meaning those plates are moving apart. And it's been occurring for 200 plus million years. You'll see that that's how far away it is. And all this is new floor on here, made of basalt. Okay, so I could almost had oceanfront property, and we would have to be going a long way to see June because she would be in Europe if the original split happened. All right? But no, we're all together right here. You can see some other typical ones. The typical one that you usually hear is California has fallen off or is about to fall off. I got news for you. California fell off millions of years ago. That split occurred. You just don't have water coming down the center. And it hasn't fallen off down. It's moving. It's been moving for millions of years up towards Alaska. And there's plenty of evidence for that. So you got to tell your friends if they say, oh, California is going to fall off. No, it's already broken off and it's headed north. And what you see is, oh yeah, Japan is a great example for a lot of the previous volcanic island arcs that occurred right next to us, and it plastered itself onto Connecticut. That's what's happening. That's why you don't want to live in Japan. There's all this subduction going on, plates are moving under it, it's got volcanoes. And yeah, it's just not a place. You want to live in a safe place? Live in San Francisco. It's all relative comparing. Okay. And of course, we're not going to have an earthquake. Well, we have some minor ones, because we are geologically dead around here. Okay, we're in the center of the plate. Nothing's happening. Everything's happening on the margins. The smashing, the tearing apart. You know, this is Connecticut. Nothing happens. Nothing happens. All right. We go on. Oh, yeah, great picture. Took all the information and figured, okay, this is probably what it looked like in the Connecticut Valley now during the Jurassic. You know, the height of the dinosaurs. Height of the dinosaurs. In Connecticut, we have one lousy dinosaur. It's like, that's at the height of the dinosaurs. See, even then, people didn't want to live here, or creatures of the land. Anyway, you see you don't see too high mountains because we've had all this erosion and weathering. You can take a mountain as high as the Himalayas, wait around 200 million years, and it's going to be flat. Okay? So I know it's a slow process, but it does happen. Remember, the Earth is 4.5 billion years old, plus or minus a few days. Connecticut Valley. See the muds? Now, I know about these because I went next door where they were building houses, and I found ripple marks in the rock now, preserved in that. So, you know, evidence is all over the place if you're in the Hartford Basin. Okay. The Triassic. Oh, notice the mountains are high, much higher in the Triassic. So this would be into your your eastern uplands. So Andover is probably right around there, I think, on there. If you don't believe me, no. Connecticut Valley, see, so you still had dinosaurs then. They were really the start. The climate was hot and dry, so the mountains certainly indicate a hot and dry climate. And at times the monsoons would come in and make it wet. So we see the pattern of ripple marks. We see mud cracks. You know, I've collected them too around here. And so vegetation was spotty. Let's leave it. Let's leave the Mesozoic and go back further. Now we have Andover and the Paleozoic. What time was the Paleozoic? I didn't hand out those handouts for nothing. Give me a time. The Paleozoic started when?
$540 million years ago. 251.
No, I'm going back. I know this is different from geology usually, but yes, sir.
250 million?
Yes, yes. Wise words from a child. Thank you. Keep us going here. So we have continued tropical climate because we're now south of the equator. Okay, that's why I say an era of no North Star. What would you be looking at? What do they call it down there? Southern Cross, that's right. So we were in an era of mountain building because we have three squeezes. The Great Squeeze 3, the Great Squeeze 2, and the Great Squeeze 1. Again, millions of years, hundreds of millions of years of weathering and erosion. Anytime you put something up in the air, it's going to come down. Just how our climate is. An era also of Andover, of no Andover, as it lies beneath the seas. See here. So another map. The Allegheny orogeny produced the Appalachian Mountains and was really responsible for the final closing of this Yapetos Sea, which we'll get into. Okay, so they're showing all the continents together, all the mountains. They show where Connecticut is, and you can see it's in the trend of all the mountains there, on there. They've got these other things you may have seen, subduction zones. That's where the plates are actually moving back into the earth. So with all this mountain building, the earth is not getting larger. There's the great recycling taking place. Plates are moving back into the upper part of the mantle and melting away. So you talk about recycling at a grand scale. That's where it is. Okay, Permian, top period of the Paleozoic. So just again, let you know, Andover is, think about that. We're in the southern hemisphere. It's part of the supercontinent Pangaea still. The big split has not happened, meaning the big split that gave us the new Atlantic Ocean. So there was plenty of creatures, there was vegetation around, as long as it was nice and wet. All the pictures, of course, are based on fossils. Then we have, going back again, Andover in the Carboniferous. Sometimes they combine the Pennsylvanian and the Mississippian into this. So the rocks, they are rocking because you're mountain building at this time. The Alleghenies or Appalachians are forming. And it says the Allegheny orogeny is suturing the continents together. Earthquakes now are a frequent occurrence around here. Right? So we did have a lot of, as I say, rocking and rolling going on. Cross section, whoosh, slice it down. Here's the Yapetos, the new Yapetos ocean crust. In another group of islands, the Taconic Island Arc. You can go over into New York and they have the tectonic highway in that, and also refers to the tectonic rocks. Southeast Iapetos ocean crust. So we're taking in a lot of ocean crust. You remember this is Connecticut now, and we're smashing in. Another volcanic arc. A place called Avalonia, another volcanic arc. Another form of ocean, the Rheic ocean crust. And then Gondwana, which are like original continents and such. So this is the big squeeze 3. Builds the Appalachian Mountains, which helps build the supercontinent Pangaea. The Iapetos and other oceans die, which I just said. Any question? Oh, I thought Junior was trying to leave already. Okay. Now we skip. We're starting to take 2 of the periods at one time, just because people are getting restless. The Devonian and Silurian. So around 350 to about 450 million years ago. The Devonian on land. You may not be able to see it that well, but there's a dragonfly here and he's got a wingspan of 3 feet. Okay, everything was large. Okay, hopefully they're not getting that large again, but just the play on evolution was unbelievable. I mean, you know the size of the dinosaurs. Well, the insects were also big. Now we go to the early Devonian, and now we're starting to get into your rocks around here. So what did it look like? The northwestern Iapetos Ocean had already been squeezed up against Connecticut and metamorphosed, meaning turned from sediment into rock. Right? That's in the western part of the state. Now we have the southeastern part with the Avalonian island arc, think of Japan, being subducted and smashed into us. See what else is not far away. We have Africa, back then known as Gondwana, South America, all heavily into the southern hemisphere. And certainly us, we're in the southern hemisphere. Okay, and that's part of the Akkadian orogeny now. So now we're on the big squeeze 2, which is we're the product of that. Cross section again. Time to get excited. Okay, so we sliced the earth down. We can see the top, but we can see down here. This is probably where Andover is as far as the metamorphic rocks. Everything's squeezed except this very old Rheic Ocean. That's still open down there. Look at the mountains. We were probably as high as the Himalayan mountains right here because we were still being smashed together. We had all these old ocean crusts. That's what's indicated by the black. Does anybody remember what ocean crust is? What's the name of the rock? I'll even hold it up. Yeah, basalt, good. Yeah, half the crowd's awake, gee. Okay. Oh, Penny, you were supposed to give us a score of the Patriots game right now? Okay.
Giants game.
They're playing. I'm not sure we want to hear that. I'm a Giant fan, but, okay, just to give you some background again. Okay, what's all this smashing together that? If you have 2 continents together, everything gets squeezed tightly. Some of it moves down. It gets heated 1,000 degrees. It moves miles down within the earth. And then it finally comes up again as solid metamorphic rock. Granite is actually an igneous rock that is slowly cooled, so you can see nice big crystals. Again, a lot of the earth is like a cake. All right, if you rush a cake, it's going to come out, stick in the oven quick and heat. It's all coming up blah and gooey, and you won't have much defined texture to it. If you cook it slowly and cool it slowly, you have those nice big holes and everything. It's good. Granite's the same way. You slowly cool a rock, and you have nice big crystals grow. The smaller they are indicates it was brought to the surface very quickly and cooled. All right, then you have down here this subduction going on, so the plates return back. This would be like one of the many island arcs that's smashed up against us. This is a good example of Japan right now. Volcanism, a lot of earthquakes, because this is smashing into this part, this is going downhill. Get to there. Oh, last thing on the egg. Last thing is on the shell of this egg. Now you know the shell of an egg is extremely thin, right? And you got that liquid inside. Do you think the shell of the Earth, meaning the lithosphere, is thinner in proportion to this egg or thicker? Do we have any votes? Yes, the Earth's crust, I forget the question. The Earth's crust is much thinner compared to this one. And think about it. So we have this very thin crust, but yet we have a lot of sort of liquid inside of this Earth. But this egg at least is at room temperature. Everything inside of the Earth is super temperature, thousands of degrees, under extremely high pressure. It's like we're just sitting on the surface. We're thinking, oh, this is safe, when really we're just sitting on a pressure cooker out there. So that's sort of the final piece of the puzzle. As you eat, they all represent the geologic processes. Kitchen and cooking can tell you a lot. My wife keeps waving to me. Hi, hon. See? She's trying to tell me something. She's trying to, I'm glad she's not going like this. Okay, big squeeze too, yes. This is forming us. The Akkadian orogeny, as I said. What does this word orogeny mean? I keep bringing it up. Intense upward displacement, usually associated with folding, thrusting, and other compressional processes. Yeah, it produces metamorphic rock, which is very common around here. And it produced the gneiss rocks of Andover. All right, so we bring this up. The Devonian gneissic rocks, about 10%. They're called the Canterbury gneiss. Anybody hear of the Canterbury gneiss? Okay, some people have. Right down here, the pink. Okay, where are the roads? So you have Route 6 come down here, the railroad. That's probably like Bunker Hill going across there. So you might be able to see some splotches of that down. You get the northern part of Andover Lake there. Canterbury gneiss, what about it? There's layering and crystalline nature, defining it as the metamorphic rock. Even by looking at the Hebron gneiss here, you'll tell what it's there. Like origin, weathered and eroded rock deposited on the ocean floor originally, which was subducted, metamorphosed, and then risen up again. So just by saying the word gneiss, you can see at least here there's a lot to go on with that in a discussion. And that's without even talking a lot about the mineralogy, which is mainly our big three: quartz, feldspar, and mica. Okay, now we're getting into the major gneissic rock, okay, which was formed in the Ordovician to Silurian time. And it's called the Hebron gneiss of Andover. See, they weren't even nice enough to give you just, oh, this is the Andover gneiss. They have to go to Canterbury, the Hebron. So it covers about 85% of Andover. This is typical outcrop again. You can usually see some layering or foliation, is the proper term, as it splits apart. Hebron gneiss. Again, textured, layered, fine to medium grain crystalline rock. Origin, metamorphosed ocean sediments from southeastern Iapetos Ocean. Minerals, chief ones, feldspar, quartz, mica, and some hornblende. So this rock is about 400 million years old. It looks pretty good. We all hope we could look this good after 400 million years. Okay, he was a little dirty, but put him in some bleach for a week, sprayed him with some clear lacquer there, and geez, looks pretty good. Ah, yeah, just another close-up of that outcrop of rock. Of course, it would be, if Junie bothered to clean it off and bleach it, it could look as well as that instead of something in the woods. Okay, we're getting to the end. Early Ordovician Cambrian. Can't forget this because this is now when Andover's underwater. This is way south of the equator, tropical climate, part of another ocean. Ocean floor is basalt with sediment accumulating it. Oh, Caribbean-like carbonate shores to the west. Nice. But you people are out in the ocean. Okay, where are you really? You're actually down here. They have Connecticut here. Well, that's where the carbonate banks were, but you were over here. Actually, probably closer to down here with Avalonia, because you got smashed up. So you moved a lot of time in a relatively short, whatever, 150 million years on that. And again, most of the continents were south of the equator. And this just shows you, okay, so you're going to be in this area here, see all this subduction going on. You see the ocean was actually splitting, Gondwana pushing on it, Tectonic Arch, this other trenches, Proto-North America here, see your carbonate shelf. And we have the limestone, the carbonate banks from there in western Connecticut. That was metamorphosed, and limestone metamorphosed into marble. Okay? So that's just proof that we were in a warm climate, and we did have very nice oceanfront property. Aha! The bottom of that Cambrian Ordovician. Some very strange creatures. Eurypterids, trilobites. Oh, wait. Oh, yes. I just happened to carry one with me at all times. It's trilobite. It's this little creature. Some of these are average size, but there's some that would grow up to be like 10, 12 inches. Hard exoskeleton. Eat a lot of things on the bottom. Plenty of these still out there as far as fossils. Always carry around one for good luck. You should. And just what it was looking like again with the big squeeze one, the tectonic orogeny, the first layering onto the old proto-North America. Ah, yes. Now, we've hit the first 500. Just one slide for the last other 4 billion years. Skip over that. Very horrendous conditions, a lot of volcanism, little life forms that were at least preserved. And now I'd like to say something about the future. Andover Rocks in the future. What do I predict? A period of warming. Al Gore and I are together on this. 1990, of course that started then, to 2190. A period of cooling. 2200 to 2400 AD. Okay, what do I base it on? You can just go back into these temperature charts, and they have a lot of evidence for this, but look at the cyclical nature of even this Holocene that we're in. So it doesn't take a genius to predict a pattern. All right, what do I see in the future then? Okay, if you're living that long, period of general warming till maybe about 35,000 AD. Oh, okay. Then, period of glaciers, 35 to 75,000 AD. And Andover continues to move north, because we've been doing that for like 500 million years. And another supercontinent forms. Humans become extinct? Very possible, because we know things don't last forever. And there's been 5 major extinctions that we know of in the last 500 million years. Ask a dinosaur. Okay. Oh, again, we bring this up because what do you see over and over and over? Get that one? Okay. It took me a while to get that one. All right. Future world. Yes, geologists do go crazy in their spare times, and a lot of them make what is it going to look like in the future? Sort of what it looked like, 300 million years ago. So here we have probably Connecticut up here, sutured again with Africa. We've become almost a new Pangea, and they actually even have names for the new supercontinents. But we're still pretty much, maybe we've actually moved down a little bit, so we've gotten a little bit warmer. So good news. And finally, the end, but not really. We have about 5 billion years left before the Earth expands and engulfs the Earth, and then finally gets out to Mars before it collapses.
The sun.
Then it'll be the end. Oh yes, I hope you recognize. I didn't start at the beginning of that. So thank you. Thank you. Hope you enjoyed it. You may come up and look at our rock display. Yes.
So Metacomet Ridge.
Oh yes.
Was formed back in the
Mesozoic time. Yeah, more in the Jurassic. As it started to split and
But you said it was underwater at that time, is that?
Well, it was very low because the rifting, it split apart. So it certainly wasn't at the elevation now. I believe there was some ocean water. There was also freshwater lakes around. I have a freshwater fossil up here from the central Connecticut Valley Rift Zone here.
So during that time then, that would have split, and we would have had lava flows.
Yeah, the lava flows were coming out more or less on a horizontal basis.
Okay.
You can't really think of volcanoes. They believe there was one in Giant Sleeping State Park. They think that's sort of the root of a volcano.
And the texture of that ridge is, I mean, it's columns.
Yes, that's the basalt. That's very characteristic of basalt. And in some places, you can go to Ireland and you see beautiful, those five-sided shapes to it. Yeah, so it's very fine grain, high percentage of iron. In fact, they at one time mined the iron along there, like Penwood Park. You go and see the furnaces still. Yeah. Actually, the last iron mine in Connecticut closed in 1917 in the northwestern part of the state. Good question up here?
They used what had been produced in World War I.
Oh, yeah?
Yeah.
Yeah, I guess that was
'Cause
the
there
timing.
was not a big demand, but they kept producing.
Yeah?
And then when the war came, it all got sold at a very high price.
High price, yeah. Yes?
Could you explain the brownstone?
Oh, the brownstone is just this arkose here that came off of the weathering and eroding mountains to the east and the west. And the climate at that time produced a lot of, let's see, this iron in the soil, went to a specific iron that was tended to be red. So that's why we result in all this sort of reddish brown look. That's why you get a brownstone. But it's, for the most part, it's not highly cemented. It is a sedimentary rock, as my friend wanted to point out here. And you get different. You get finer grain ones, silty. This has some very noticeable grains in it, almost up to what they call a conglomerate, where you have rounded pebbles in it. What else do you want me to say about it?
Does it easily erode?
Yes, yeah. You can have a piece, you can put it out in the beginning of the winter. By the end of the winter, it's all broken up just from the water and then the freezing getting into it. So it's not a good building rock, except for some places where they were getting it down in Portland and using it in New York brownstones. But for the most part, it's really crummy. Yes?
What would that smooth rock right there be?
This?
Yeah.
This is a shale, and this has the fish fossil in it. So the black indicates a lot of carbon, clay material that was in a rock, then it's a shale. So you can see the scaling of the fish on it. So this fish is, roughly about 200 million years old.
Wow.
Yeah, and as if,
I thought it would be like slate or something.
well, if it's metamorphosed, this is subjected to high temperature and pressure, then it would become slate. But this is a sedimentary rock type right now, a shale. And if you're just holding the original material, that's just called mud and clay. So, same stuff, they keep changing the name as it turns.
It would be sedimentary?
Yeah, this is sedimentary rock.
Like made up of all the sediment?
Yes, very good. Sedimentary rock.
That's from Connecticut here?
Yeah, this is from the Connecticut Valley. Forget exactly where I found this one. Yes?
Keeping in line with our friend here, on the Railroad Trail, there's a couple of examples where there's a big boulder, and then on top of it you see the sedimentary rock. What causes that?
Somebody playing games with a geologist? No, you shouldn't have sedimentary rock around here. Is that true? Is that true? Yeah, it's like, yeah, is it rock or just appears to be solid?
Well, you got
Oh.
solid boulder,
I mean, a lot of the,
a layered rock on top.
yeah, well, okay, it could be ice. When I was looking at several outcrops, you could really see the layering or the foliation occurring, and I could see to an untrained eye, it might think, you might think of that it's a sedimentary rock, because it almost looks like the natural sedimentary layers.
It almost
'Cause-
seems like, that sedimentary rock or whatever it is formed on top of the big boulder.
Yeah, I'd have to see it.
Let's take a walk.
We got another question. Yes, sir.
Would, right about, like that,
Yes.
like that.
Yeah, you could see that.
there, would that be, Hartford or something like that?
Oh, yeah, Hartford's
'Cause I recognize.
right here.
Like the field trip.
Yeah. So these are the borders up valley. So Connecticut spread apart this much, and then all the sediment from the mountains came eroding down into it. At the same time that it split, they had all this magma moving out here. So the red, orange indicates the magma. And then it started to move down. So we see the edges here, and that produces sort of the cliffs.
So it kind of like slanted a little?
Yeah, it's slanted because this side dropped down. Bloop. That was called a door effect on there. And this is where Avalonia and such got smashed into us. And this is the original North America up here, the billion-year-old rocks. Any questions? Answer. Yes?
Did the glaciers bring a lot of random rocks from up north down here? In other words, can you find a lot of rocks around that may not necessarily have originated from here, but came from somewhere else?
Not as much as going to Cape Cod and seeing the assemblage in those cliffs of the rock, because I've never noticed that, I've been around Connecticut, you can usually see the rock that's close by. Yeah. But you go to Cape Cod and you see things that it's like, well, this had to come up from Maine because you're finding sort of a sedimentary metamorphosed rock, and the only closest place is Maine. So it was a good dumping ground. I didn't stay long enough on Long Island to find out like that, but you probably could find some weird ones, but I think it was cleared off most of that, and then it just started to pick up and grind up what was ever it was touching as it moved down. The other thing, yes?
So let's say that rock on Long Island that came from Maine, how many years did it take to get there?
Oh, I haven't read anything about how fast the glaciers were let's say, moving down, but, maybe 1,000 years. Some of them move very quickly. They're able to predict if somebody falls into a glacier like in the Alps, they can predict when that person's going to show up on the end. And they're moving like 25 feet a year, some of these glaciers, some of them even moving faster. Yeah, but they can actually, you fall in that crevasse, okay, your relatives can pick you up here 75 years from now. Yeah. Any other thing else, or you're invited up to see these rocks too? Yes?
So, not to disparage your rocks here, but like the interesting rocks that we find in Connecticut. I
Yeah.
mean, the garnets this big that are popped on top of a boulder, or the pretty green granite, or
Yeah.
those were formed after the glaciers.
Oh, formed well before the glaciers.
Before. So
Yeah.
how did they not get ground away, or where did they come up from?
Okay, I mentioned earlier on, first of all, you have this isostasy going on. Because we're not on a solid surface, we're on this sort of molten, plasticky earth. Okay, so as you take weight off, it rebounds. It's called glacial rebound. They've had over 300 feet up in Canada that they can record that the ground is now that 5,300 feet of ice is off of it. And the same here, they've had some of that. Plus, as you erode things, it comes up and continues to weather and erode, exposing new type of, let's say, outcrops or minerals.
Just gotten pushed down.
Yeah,
Not
so-
really changed. I mean, they didn't.
No change, no.
Yeah.
No change. Your greens, I forget, associated with basalts, that's all in the that Jurassic Mesozoic period of flows. All these garnets are you back in your Devonian, Silurian to Ordovician time?
So they really didn't just get ground away, they just got pushed down and then they...
Well, they got ground away. There was a lot of grinding, and just plus their weight is moving it down. There's always a number of processes always working at the same time. I hope that clarifies
Any
things.
money makers, gold or diamonds in Connecticut?
If I knew, I wouldn't tell you. And if I did, I wouldn't be here. Yeah, Sunday afternoons here. Yeah. No, they had, the Yukon geologists had found some specks of gold and something, but usually that stuff is wiped away early on in your newly formed mountains. The gold and all the minerals are really up in the top of it, meaning they've moved up first in these hydrothermal deposits and that, so all that was eroded away and out to sea. The other question for the cause, otherwise you can look at the rocks in the highlands, in the lowlands, and such.
Thank you for coming.
Thank you. I appreciate it. I appreciate the warm welcome.
He loves his subject. He treks up the White Mountains with his 4 grown-up kids.
And my one old brother-in-law.
Give them another version, and he treks around the Southwest with the kids when they were growing up to look at more rock formations. And one time he was on in the Finger Lakes.
Oh, that was great,
in a
yes.
boat with one of my other boys, and it was a trilobite that you found.
Well, you had trilobites on the back, but when I was snorkeling in the lake, the whole bottom of the lake was these Ordovician horn corals. Horn corals formed in an ancient sea, and now I'm finding them in a freshwater lake on the bottom. That was
He sent my
fascinating.
son back to school with these to delight his science teacher.
Delight.
So, thank you
So,
very much.
I'm delighted to be here. Thank you. Appreciate it. What's